Welcome to this video on ray diagrams for converging mirrors. Now, I started by explaining all this process through lenses, so if you haven't checked those videos out, I go back and check them out just to make sure you understand what the heck is going on here. Alright, first things first, we're going to follow pretty much the same rules as before. So the first thing I'm going to do is I'm going to place an object somewhere, and I'm going to go ahead and I'll place the object maybe right about here. Now I'm going to have the first ray go in parallel to the principal axis and hit the mirror, and what's going to happen is instead of it refracting, the mirror is going to reflect the light and it's going to reflect it back through this focal point based on the angle that it hit at. Now, if I were to actually measure this using Snell's law, what I would need to do is I'd need to set up a normal line to that point, and I'd measure this angle, and they'd both be the same. But the process of doing the ray diagrams is to help eliminate having to measure angles. So we're going to use the same process as always. Our first ray goes in parallel to the principal axis. Our second reflects, through the focal point. Now we're going to have the same thing again. We're going to have a ray go through the focal point. So we'll go ahead and do that. From that same point, hit the mirror, and it's going to reflect back parallel. So it will come out kind of like this. Now, I didn't actually line those up very well. Let me go ahead and try that one more time. So from that same point over there, it's going to reflect back. Okay, now the point where these rays actually intersect over here is going to form the real image of this object. So here's the object, and the image is formed over here, and it's a real image. It's a real image because actual light rays, here in this case reflected light rays, actually intersect here. We also see that it is inverted, okay, from what the object is, and it's smaller. And it turns out the same rules are going to apply that we had with the converging lens, where if the object is placed outside of both the focal point and the center of curvature, remember for the lens that was the same thing as saying 2F, you'd form a real image between F and C in this case that's smaller and inverted. So it followed the same principle, except you may have noticed that for lenses, real images always formed on the other side because that's where actual light rays, real light rays go. And for real images on a mirror, the images form, real images form on the same side because the actual light rays reflect onto the same side. Let's go ahead and do an example again, and let's see if it does follow the same rules, where if I place the object on the focal point, which that's a little bit off of the focal point, if I place the object on the focal point, will it do the same thing as it did before and create no image? Let's see. So I'm going to do my first ray in parallel to the principal axis, hit the mirror, and then it's going to reflect through the focal point over here. Now the next one is a little bit harder to do because I'm supposed to be able to go in parallel or in through the focal point and reflect parallel, but I can't do that. The third ray would actually go in along the center of curvature and reflect back along itself. That's one option. Now another thing that I can do is I can hit this middle point right here, and it will reflect back at exactly the same angle. So let me go ahead and do that one instead and see if I can get it as close as I can. Be a little bit difficult here to do, but let's see if we can manage that. So it's going to reflect back on this side, and that's approximately the same angle here and here. And you see that these rays will never intersect, so no image has formed. So it's the same thing as you would have had with the converging lens when the object was placed at the focal point. Let's place, in this final example, let's place the object inside the focal length. Okay, so Perhaps we place it right here, and I'll make it again small because I know that it's going to come out magnified, and this is a magnifying mirror. Sometimes little makeup mirrors have this. Now they're not as curved drastically, but if you get close enough to it, you can see a magnified version of your face. So I'm going to go do the same rays again in parallel to the principal axis. I'm going to reflect that ray back through the focal point. Now I know it passes through the object, and that's totally okay, because what essentially is going to happen here is I'm going to try to get this ray on this side to trace back, because I know if it follows the same rule, I won't be able to form a real image. Okay, now I'm going to go in line with this focal point. So it's going to hit right there. Now keep in mind, this portion over here is just a guide. So I'm going to erase that, but I'll leave the dot on the axis, because what I did was I lined up this incident ray with the top of the object and this focal point to have that ray drawn. Now it's going to reflect parallel to the principal axis. So it should be something like that approximately. Now I see these two reflected rays will never intersect because they're diverging on this side. But if I look into this mirror, my eyes can actually trace back those rays. So I'm going to do a trace along the reflected ray only here, and then another one on this reflected ray over here. And what I see is that the point at which those two appear to intersect, so my eye would have to be somewhere here to be able to see those points. What happens is this would be the corresponding point to this right over here, and I've formed an image that is larger, so it's magnified positively, it's upright, in other words, same orientation as the object over here, and it is a virtual image. And it makes sense because a virtual image has formed almost on the inside of the mirror, or in a place that's it's not in real space, right? There's no actual lines or light rays have intersected. It's actually my eyes that have followed those rays back to that point. In the next video, we'll take a look at a diverging mirror and then add some other examples.